Hello, my name is Simon Park, and today I am going to talk about the two-sample t-test. When scientists develop a new drug, they want to see if the newly developed drug is more or less effective than a drug that already exists. There might be many ways to determine and answer this problem, but one way to do so is through the two-sample t-test. A two-sample t-test, also known as the independent samples t-test, is a test to calculate if the means of two populations are equal or different. This means that this test can be utilized to test if a new process, treatment, drug, etc. are superior to a current process, treatment, drug, etc. A t-test is used under these certain assumptions. Two groups, samples are normally distributed, samples are independently observed, and the samples have the same or different variances and the data are paired or unpaired. Thus, two common types of t-tests are unpaired and paired t-tests. If you're using an unpaired t-test, you are assuming that the two samples or populations have the same variances, in other words, standard deviation. Conversely, a paired t-test does not assume that the two samples or populations have the same variances. To use the two-sample t-test, you need data values that are independent and are sampled randomly from two populations. Also, you need a hypothesis that generally states that the two groups' means are different. For example, you could say we want to calculate if we have evidence that shows that the means of independent variables are different. Before you actually start the calculation, however, you need to set your p-value. This is the percentage that is used to compare if you have enough evidence to conclude that the means are different. If your t-value, values that we are calculating, is less than the p-value, which you usually set to 0.05, then you can make an assumption that you have enough evidence to show that the two means are different. You can't make such an assumption, however, if your t-value is larger or equal to the p-value. In such a case, you cannot be definitely sure that there was no difference between your two means. Thus, you should be wary that perhaps you did not have enough data or the data was wrong in any way. Your t-value is calculated by the quotient of the difference of the two means and the standard error. Standard error, then, is calculated by the quotient of the standard deviation and the square root of the number of samples. A common mistake that is easy to make while using this test is that one might think that this test tests for correlation. This is false, as this test only compares significant difference between two means. And that's it. Thank you all for watching.